Hello and welcome back to Hocus Pocus. Today we're going to be talking a little bit about probability, which is probably one of my favorite subjects. The basics of probability, like once you actually get into how it works, it's actually not super complicated. Like once you understand like what the different things mean, it boils down to basically multiplication and addition. So let's go ahead and jump right into it. We'll say, for example, your odds of winning the Super Bowl are 50%. No, 25%. These are your odds right here. We're just gonna pretend like all of these are the same size. These are your odds. You have a 25% chance of winning the Super Bowl in this particular series. So your odds are, by a factor of three times worse than betting for the other team. So those aren't very good odds. So if you have a 25% chance, that's 1 in 4, and the betting on the other team is a 3 in 4 chance. Now probabilities always add up to 1 or 100 if you're talking about percents. So there is, like, if you were talking explicitly about events occurring and the events must occur, they will add up to 1 because 1 is a certainty. If you have, like, I don't know, a coin that you flip it and there's a 0.01% chance of it flipping on its side, then there's a 49.9995 or 4 or 5% chance that it's going to turn into that it's going to be heads, and then that's going to be flipped on the other side for tails. I'm not sure if I got the number of decimal places there correct. I was kind of rattling that off, but you see my point. If there is a faulty condition that you're taking into account, it will still add up to 1. So let's make this a little bit more complicated and say that you're not looking at winning 1 Super Bowl. Your bet is if you win 2 Super Bowls in a row. And hypothetically speaking, we're going to say that you're guaranteed. You have a guy on the inside. He's going to get your team in. But once he's in the Super Bowl, all bets are off, and you still have a 25% chance of winning the next one. So does that mean we have a 50% chance? No, it doesn't. What it means is that this 75% gets carried down because these events are independent. So you now have the 75% bar, and you are chopping off another quarter of that. So, in this case, you have the 3/4 up here, and then the 1/4 of the 3/4, so you have a 3 in 16 chance of losing this Super Bowl, but winning this one. And because we're looking for at least 1, that makes sense. So, the odds of winning either this one or both is... Can you see that? Let me bring that up. All right. Is 7/16. And you know, that's pretty decent odds. It's not 50%, but it's pretty close. So let's take this a little step further. What's the chances of... We're stepping into dependence here. So this is a more independent scenario, but if we want to look at the odds of winning both of them, then what we're looking at instead is this is the 25% of the original. This is the chance that you win this initial Super Bowl, right? So we need to win the initial Super Bowl, and then we need that original, that second quarter. So your odds of winning both of them are not 3/16 or a quarter or like an eighth. It is 1/4 of 1/4 of a chance, or 1/16. So these odds are pretty low. And let me just take a break here for a moment to talk just a little bit about why I like probability so much. So probability is, if you like video games at all, I kind of like video games. If you like video games at all, a lot of things are up to probability. From the ranges you hit in Pokemon, to the odds of effects triggering in roguelikes, it all boils down to probability. So, if you have, for example, like you're playing Risk of Rain 2, and you have a tougher times, you know, he's over here making sure that you don't take damage on that 10%. And you have one of them, that's a 10% chance. And you, like, it's fun going through and like calculating all of the permutations, how well it stacks. It's kind of neat, right? And if you're a gambling person, you might not be if you know a lot of probability. I mean, knowing a lot of probability can kind of help you affect your success rate, but if you know probability and you know the payouts, generally speaking, you're going to look at those and realize that's not in your favor. And if you go through and you look at lottery winnings, or the or the odds of winning blackjack, the reason they say the house always wins is because the house does have an edge. There is a certain percentage chance that they will win more often than you. And that stacks up over time. So if you continue playing at the casino, chances are you're going to lose money over time if you're exclusively playing within that bounded set of rules. So probability is a lot of fun. And it's really interesting to sort of get in the nitty-gritty and like break things down and sort of understand what's going on there. So getting back into it, let's say, hypothetically, we're looking at not the odds of getting at least one, or the odds of getting exclusively both. Let's say we want to look at the odds of getting only one, right? So this isn't only one. This is the odds of getting at least one. So how do we do that? Is there like a quick formula to sort of like get exclusively that? You want to dive in and you don't really care about either of these two options. You only care about that one? Not really. The best way to find at least one within the probability paradigm that, as I understand it, is to take the chances of getting at least one and the chances of both and subtracting them. But how does that work? So, if we're looking at the overall probability, sorry, can you see that? Yeah. So, this is the odds of getting none. This is the odds of getting the first one, independent of getting this one. So this is just one not caring about that. And this is getting this one while caring about this. So getting both is kind of like the difference between these two, right? So the odds of this first one is an independent portion. But if you crack that off and you make it sort of like a little bit dependent on this one, if you try to make its portion the same, you end up splitting off the portion where you care about getting both at the same time. So if you split that off, you break off the 1/16. This becomes 3/16 from there. Right? So if you remove the probability of getting both, you are left with only the probabilities of independently getting one or the other. Right? Does that make sense? Okay. So I think that's most of what I wanted to talk about with this one. I think that the next video idea I have is going to be something I know showing off a little bit of like some brief easy Python stuff that that kind of trivializes math, because like if you're able to get competent at writing Python, it's way easier and more encompassing than using a calculator. I think that might be fun or interesting to look at. So that's been it for this. We looked at probability today. I hope you found it at least a little bit entertaining. But that was Hocus Focus, and I hope you have a wonderful day.